Let's look at a few specific cases. Now, of course, now I'm going to also start talking about images. So here, imagine there is an image, and this is a striped image. Of course, I'm giving a very simple synthetic image. And we're interested now in what would be the frequency spectra for this image. So the frequency spectrum of this would basically be, again, repeating peaks, impulses at the various frequency, because again, it's a repeating signal. From here on, basically, you see there is a line this way, and then of course another one and a lighter one. And basically, there is repeating frequencies this way, which basically, again, you can see by looking at this signal. So in essence, what it can do is, if we were to represent this image in a frequency or a domain, basically now getting more information about the structure, especially in this case, the repetition of the signal. Just to make us understand this, now I've flipped this image. So now repetition is in this axis. And as you may have predicted, in essence, the Fourier spectrum or the frequency spectrum is also rotated. And now the repetition is basically in this direction. What would happen if I actually now rotate? So initially we had this line this way and that way, and now basically we're going to rotate it so it's 45 degrees. The frequency spectrum now, of course, has a dominant axis going this way. So if you notice, all of a sudden, this is giving us a very interesting way of looking at images, and also allows us to look at, for example, the frequency spectrum, which gives us, among other things, kind of where the orientation and the repetition is happening. In this case, the repetition is happening in this axis. Well, it found it and modeled it very nicely. Now, of course, these are images. If you notice, the gray values and the intensities are different for each and every one of the three examples we looked at. But these are just to kind of showcase the repeating patterns of images. Let's look at the first example we started off with, but this time let's add some noise. So I've added some noise. Again, hopefully you can see it. What do you think is going to happen here? Of course, because of noise, a lot more information and again, more frequency spectra information is there. But again, the dominant structure is visible again in terms of the frequency spectrum. Let's look at all of them together. Just notice here the variation, just because of the signal here is shown this way, in this case shown this way, and in this case shown, of course, again going this way.